Where's that darn fillet? All right, pretend that's fully constrained. So now I can do a sketch. And you see we have this pull down. We could have done this on path instead of on plane. And let's see, we pick this path. It will never default to 0% of the arc length. You can do it at a particular arc length. Like if you wanted to start, say, 1 inch from the end, you could do that. Or if there's an existing point, you could say that that's where you wanted to actually place the curve or the sketch. But I just tend to use 0%. The orientation, you see the default is normal to the path. All right, that's usually what you want. All right, so let's say that we have some kind of a. Can you take a little nap? All right, there. So let's say that we have like a power cable or something like that. All right, so we could then, there's a sweep on here. All right, there's a lot of different ways to do sweeps, and they're not really, the one that you would think it would be usually sweep along guide. A lot of times this one doesn't work out for me, just like golf. There we go. We got easy. It went easy for us that time. So sweep along guide, if you're lucky, will do the trick. A lot of times you'll need to do another type of sweep, like a swept sweep. But anyway, this is that's all you need. Okay, so that's how you would do it if you did not have a nice circular cross section. You had a cross section where you had to actually do a sketch and then sweep it. This one, we got lucky, a sweep along guide worked. When you start going off into other 3 dimensions, that tends to get a little bit messed up because the orientation of that thing wants to twist sometimes. All right, so that was how you would do that. All right, now when you go in to do this sweep, there's this little subtle thing that you'll need to watch for. All right, have the tangent curves, have it seek out as it goes through this thing where those tangent curves are. That way it will follow those curves and it will avoid these theoretical intersections. You need to leave those there, but if you have that tangent to curves, the follow fillet, it will go and follow those curves there with this enabled. All right, then what you're going to do is you're going to go in here and learn how to make the mirror image of this, okay? So in a lot of industries, there's a lot of time and expense in getting one side right. And what you want is to have the other side be the exact same thing as the right side, but be the mirror image of it. And you want to be able to, if I go in here and make a change to this side, you want to keep it nice and parametric. And you want this side to update when this side gets changed. You want to keep it associative, is the word that I should have used there. You want to keep it so that they're linked together, so that when one changes, the other one follows and changes with it. So that's what this is about. What you'll do is create a new part, and then you'll use for the first time this semester this wave geometry link. So what this does is this actually goes through and finds geometry in one file and brings it into the other file and lets you use geometry that is associative, that will update when the other changes. All right, and we'll leave off for the fourth tube. We'll do something like that later. But for now, that's what it is. So do you know how to make points? We didn't talk about how to make points, but I bet you already know how to do it, right? What do they sound like?
Lines.
Yeah, so points and lines, and what else goes in that list?
Plane.
Points, lines, planes. What does that sound like? How do you go in here and just make that kind of? Yeah, they're datums. Okay, so you come up here to where the datums are, and you see there's a point. All right. I should probably start a new file. I think this one is metric even. Well, that's interesting. We're good. Put this on the desktop. Oh, let's see. All right, so we want to come in here where datum planes are, and we will insert a point, first of all. Now, what do we got to be careful about? We got to be careful about what coordinate system we're putting this thing down in. All right. Which one do you think we ought to use? Yeah, I think we ought to use the absolute. I think you'd have to give me a real compelling reason for doing something other than the absolute. And there may be one, but in this case, I don't see one. Okay, so we'll just put in these points here. Be careful. This first number is the radius. It is not the coordinate there.
So we don't put it in.
Not yet. Yeah, the 22.865. Y is what it is. I won't read them out so you. Whoops, I can write it. 6 and Z is that, and I'll hit apply. All right, so if I hit apply, then I can keep making points. So there's that first one out there in space like that. Again. All right, point number 2. All right, make sure you've only got 5 points when you get done, because it's real easy to go in there and mess one up. Actually, hit OK twice, put a point on top of a point. Had a couple people have their geometry messed up because they put lines on top of lines. That's something you want to avoid. All right, so you may not be able to see them, but the points are in there. All right, now the line that you want to use is in here under curve. It's not the sketch. The menu, insert a curve, and then a line. Now he sees the point, he sees the point. Oops. I need to say apply. With a continuous curve or something, that's probably what I'll do. Alright, so there you go. See, it's just got that subtle little bend in it. Ever so subtle, and yet a nightmare for manufacturing. All right, I don't know if I'm going to need it or not, but I would like to put a plane in here where my start point is. Let's see if we can do that. Put one there, and then another one at a distance to that. Alright, so that identifies where my seam is going to be. In fact, I don't need to look at that one. I'll clean that up a little bit. So what that would also let me do is if I actually needed a point there, I could generate a point at the intersection of that plane and that line, and that would give me a point if I needed it. I don't know if I need it or not. I can't remember.
So
Yeah.
what's the type for the original plan?
For the original plane?
Yeah.
Let's see. I think I did points, curves and points. You can also do point and direction would let you do it. But I'm not even sure we need that right now. Let's see. All right, now we need the tube is a type of sweep. So you see under here, insert. A few minutes ago we did a sweep along guide. They've added this, by the way, this swept volume. This is a very nice thing to have if you're doing tool design, cutting tool design, because what it lets you do is actually model the path that a solid would take. So you can take a solid like this and drag it through space and actually sweep out, carve out the path that would make, which is what you have when you have like a grinding operation. If you're grinding a cutting tool or something, you're actually cutting, you're pushing through space that solid shape. So I was really glad to see that get added on there. That had stopped me on a project before because I couldn't sweep a solid. All right, on the tube, before we put the tube in, we need to think about the outside diameter. I think it's 0.875. I think it's 7/8 tubing. The inside diameter, I forget. I think it's 90 thousandths wall. Seems a little bit thick. Minus 2 times 0.090. Oh, I haven't, it's not time to put the tube in yet, okay? Yeah, because we need to go in there and put the little curves in. I'll just show you this up here. See, while I was getting ready to put that in there, I knew I had to come up here. A lot of times when you're selecting curves for different things, you'll want, different items will come up here for your selection and how you want them to work. Like when you extrude a sketch, you might not have noticed, but you have the option when you extrude a sketch to extrude all of the curves in the feature, or connected curves, or individual curves. You can go in there and select curves and only extrude certain parts of a sketch. So this is something to watch when you're trying to select curves. Yeah, I think that's a stay. Let me just copy that out. All right, so yeah, we need to put in our fillets. It's under here, fillet, or insert, curves, lines, and arcs. And what we want is an arc that is tan radius. Notice all the options you have in there. Maybe too many. Tan, and our radius, 2.5. In fact, what would be better than that is to actually go in and define a variable radius, but you knew that. Oh, let's see, this is the one that's going to give us trouble, isn't it? this thing give me fits before, but I don't remember what the solution is. We'll just see. Insert curve, lines and arcs. There we go. Just get zoomed in when you do it, and he'll be more likely to see what you're talking about. Oops. Oh, also you'll notice up here at the top, you might have picked up on this. You might not have. Up here at the top is the last command. Oh, let's see. The last command that you used. You can pull it back up. Or you can pull up the history of the last few commands that you've done. Sometimes that's handy if you're doing the same thing over and over again. You keep dismissing the dialog box, you need it back. This little last command thing is pretty handy to have. I will tell you, there are some good ways to pick up NX. There's some better people on YouTube and things like that. There's a guy. Not a guy, there's a company called AliPLM that does a lunch bite section. They spell it B-Y-T-E to be clever. But it's those are actually really good.
So we trim it now?
Yeah, that's what I'm trying to remember. Let's just see what happens. Yeah, let's see here. Insert a sweep somewhere. There's a sweep. And this is a tube. And outside diameter 875. All right, so we want him to do tangent curves, and this is the most subtle little thing in the world. Okay, this follow fillet option needs to be enabled. There we go.
Will it also work if you select individual curves?
You know, I don't know, because the curve actually runs out. The curve actually, the tube actually has to depart from the curve. So it may work, but I'm not betting on it.
What was your equation for that?
Inner diameter equation again?
Oh, it was the thing to know is that I think it's a 90 thousandths wall, 0.090 wall thickness. And so I just said the 0.875 of the outside diameter minus 2 of the 90 thousandths wall. .6950 is what it works out to be.
What does it mean when some nonlinear God objects must be smooth with ES10?
Well, it sounds like it's missing that fillet. I mean, it's not following the fillet. So make sure that you've got, let me go back to this. Make sure you've got tangent curves enabled, and make sure that you have this little follow fillet enabled. If that's not turned on, he's not going to like it.
You
And
don't like sharp corners in
how the tube? Because see, he's trying to actually make tube, and it becomes really ambiguous if it makes a sharp curve. And in fact, if these radiuses got too small, it would start to cause a problem. All right, so now he didn't seem to have any problem doing that, but it might be that I would like to have a seam there. All right. Y'all know how you can do that? All right, there's a thing. Sure. I'll just delete it out of there. All right. I said insert. It's a sweep, namely a tube. The inside diameter, the outside he wants first, 0.875. The inside diameter is 0.695. The path, before I select the path, I need to make sure that tangent curves is enabled and that follow fillet is enabled. So stop at inset. Follow fillet is enabled, tangent curves is enabled. That should allow you to just go in there and do that. Oh, the thing I was wanting to do might not work. Let me try this. Yeah, let me try that. Let me do that. Yeah, I was wanting to do a trim body. A trim body can work a lot of times, but it's not going to work in this case because he wants to split the whole thing up. Let's see. Yeah. So a trim body trims a solid along a plane. So, yeah, I was wanting to do that, but let's see. Oh, maybe there's a setting in there. No. I mean, I could make a sketch and then extrude through and chop it with something like that, but that just doesn't seem. That'd be a better way than that. Oh well, I'll just ponder that for a while. Anyway, I've got it marked on there if I need it. All right, y'all want to see how to do the other side there? Mm-hmm. Okay, so remember that we have learned you know what I should have done? This should have been an assembly. Let's see here. Oh, okay, yeah, it says create here. Okay, so what we need to do right now, we have a subcomponent in an assembly. Okay, so, but we don't have an assembly. So this needs to go into an assembly. So what we could do is go out and make an assembly file and then import this into that assembly file. Or what we can do at this point is just make a parent for this. All right, so we're at a subassembly level, or a component level basically, and we want to create a parent for this. All right, so we'll just go out there and do that. Now, notice what we've done. We now have saved ourselves all the trouble of going out and creating an assembly and then inserting this this component into that assembly. We just said, look, this is an assembly. So we have an assembly that has this component in it. All right, so
have an individual PRT file with that.
Yeah, there's. See, we're in assembly PRT, looking at the right side PRT. It's already assembled in. See, this is what you see at the assembly level. This is the bike, or I called it bike. I should have called it bike right, okay? Because we need to make the left side now. All right. Do you remember how when you're in an assembly drawing, to go in and make another component of that assembly? We did this when we talked about your semester project, but I'm sure that it didn't, I don't know, we didn't really practice it, okay? So let's practice it now. What we're going to do is create a new component, but make sure, first of all, that we're in the assembly, okay? We don't want to be at bike level, or at the frame level, frame right side level. We want to be at the assembly level, so make sure that the file that you're in is the assembly. And And we will create a new component. And we'll call this bike left. I'm going to call it mirror just to remind me that this gets generated as a mirror. I don't want to select any objects, I don't think. Need to read my cheat sheet. Let's see. Do that. All right, so then we will now. Now what we want to do, we will make that left side the work part. Okay, even though we're in the assembly right now, we're looking at the right side, we're also looking at the left side, but there's nothing to see just yet. Now what we want to do is we want to step down into the left side and make it our work part, just like that. All right, now we'll insert. Let me just make sure I'm doing that right. I do this once a year. Yeah, associative copy, wave geometry, and the type is mirror body. All right, so insert, associative copy, wave geometry linker. We need to say that we want the mirror body as our type from this wave geometry linker. There is the body. The plane that we're going to mirror around is this plane. When we did the actual model, it was in the correct position already. When I gave you the points, I had already done a transform of those points and positioned the actual X, Y, and Z points such that they were actually in space in the correct assembled position. Does that make sense? So this plane down the middle, in this case the XZ plane, actually defines the midline. I want to make sure that Fix-It timestamp is turned off. That way, if I make an edit over here, it will update the edit. I want to make sure that it's associative. That's when I make an edit on one side, it changes to the other. I can also stop it, if I fix it at a particular timestamp. So I can make it associative and then fix it. The threads, you can see the threads would make the threads could be something squirrely, okay? Because you don't have, if you mirror a helix, then it's going to become a mirror image of a helix. But we don't have that problem. All right, we'll just say okay, and that should be it. Okay, tell me why does the right side of the frame look all grayed out like that? Yeah. We are right now working in the left side. We're in the left side. All right.
So a question.
Yes.
When you say you created an associative copy, can we edit either component?
Yeah. No. When we make an edit, we need to work on the right side. Let me. Yeah. I don't. If I go to edit this, then it actually shows what's in there is the wave geometry linker. So if I try to do anything with it, that's what I'm going to get. All right, so I'm going to go back all the way out here to this. Now, let's say that I wanted to design the seat brackets or something on here, like these things. I didn't have a print for these, and I wanted to actually go in there and design them based on what I'm actually looking at here. What do you think would be the sequence of operations there? Yeah, you got it. So we would create new. What would we, it'd be a model. We'll call it seat bracket, I guess. All right, what do we select? Nothing. We just want an empty file there. Now, so we can go in here to seat bracket. We can make it the work part. And we can come in here if we want to, and we can put a sketch in. And if we had geometry, I don't have a CSYS. I thought that would have come in when I did that. Oh, there it is. That's there. Yes, okay, now I'm awake. And I can come in here and I can actually see this thing. Now, you want to be careful about creating, you can in fact go out and you can gather in information where this point is, for example, and where this other side of the frame is. You can go out there and you can get that information, but be careful, because what you can never do is build what you can do, unfortunately, but what breaks is when you build a circular reference. Okay? In other words, you define something that needs something else before the other thing can happen. I don't know how to explain it to you, but it happens and it's terrible when it does. All right. In other words, you define how this thing is positioned in space based on these other pieces, but you try to link back to it, and I don't know. It's easy to do. You'll see at some point. All right. So I would need to actually come in here and constrain this part. Well, 5.5 sounds good to me. Oh, let's see. I just made that. And we won't use 1.6 inch to flat bar, maybe 1 inch flat bar. There we go. That looks a little better. All right, and what you can do after you've gone in here and made the thing is you can go back out to the assembly, which is just a click away, and you can constrain it just like you would have done the other things. Okay, so you can come in here and you can just start by moving it. You just want to move it around. You can do just like you've done before with assemblies. You can work with it. There's really no difference. And then you can go in there and do a mate constraint and do you probably want to put a midline. You can constrain the midline of this to the midline of that kind of thing. Just take a little bit more care. But anyway, that's what I want you to do, is understand the general procedure there. Making parts inside of an assembly. So when he's asking for points and things, you can actually tell him, look, you want to work in the assembly, you want to work just in the part that you're in, like the work part. You can work in the work part and subcomponents of the work part, or you can work in the entire assembly. But I'm just telling you, if you do that, like if I go in here in this part, and I've said that this part relies on some geometry on here, then it doesn't make sense by itself anymore. It's not a part that I can use, say, in another mini bike. Okay, I need to be careful that I don't constrain it to this bike. I mean, I can constrain the position, but if it's the geometry that's making the part, I need to not use the geometry that's here to actually create it. Otherwise, they have to go together. All right, y'all have any questions?
When is this due by?
Take a week on it. That's
3-4
fine.
weeks.
But you've got. I don't want to give you too much time, because then you'll wind up pushing your project off, that kind of thing. Not doing your project? Yeah, we'll see you next time. Oh, and also, see, look, once I've made one C bracket, I can go in there and just put another one in. So I can put as many seat brackets in as I need now. It's not like it exists in there as a,
Yeah, I think it'd be like maybe 32 or 3 times.
it's no different than any of the other constraints that you were doing, or any of the other assemblies. Yeah, let's put it this way. And I could use that, you know, that'd be a good reference for something.
Just copy the system brackets?
I don't know.
How did you create a second one?
Well, this is just an assembly. So all I did is I just added another one, just like I did before. So it's the same, and see, he's bundled them together in here because they're the same object. And I can break that bundling out if I want. I can do this unpack, and there'll be two in there.
So one thing that I can help you create a C bracket in component,
Yeah.
create it as a subcomponent.
Oh, you just made it wrong.